Hello, today I'm going to present you the Branchers Pavilion. It is based on a study of algorithm-generated assembly of curved wood for temporary shelters, and I'm Anton Kerezov from the University of Tokyo. On this project I worked with two of my lab members, Tatsukiya Suda and Firas Hawasli, for which I'm really grateful, so that we managed to make this kind of structure, pavilion structure made of forked and straight branches. And here is a short video of the same structure. So for the people that couldn't see my presentation on the full paper, I'm going to include some short theory, explain how and why we make this pavilion. So basically, I proposed a workflow from the forest to the construction that is not gonna use traditional construction techniques. And the branches are going to be harvested from plantation forests into a predefined shape, then transported and scanned by the people or institutions that want to use these structures, and then this data would be transformed into point clouds, meshes, centerlines, and then assembled into several options from which the end user would choose one to build. So I went to the forests to pick up some branches. Actually, the forest is on the back of the cameraman, and I could find these 30 something branches that were then later scanned, and some design limitation guidelines were created so that only forked, single forked, and straight branches without any forks could be used. After that, each of these 3D meshes were analyzed for a center line and then simplified into a triangle from its endpoints. Because I proposed this kind of shell, 3D shell structure that can accommodate any number of randomly sized triangles, which are the branches, and it can expand by this red expander unit that could be placed in each one of the joints, which are here. These are joint points, so that the structure can grow in any direction. And for this to work, I propose two structural models. One is with a rigid joint that could have different shape depending on where it is in the structure, and this is used for the pavilion prototype I'm showing today. And the second type of joint is a pin joint connected with tension cables that by trying to minimize to a single point exercise compression on the branches. So this research was not done specifically for this competition, but in order to fit into the requirements, I had to trim the branches to the required box size so that they can fit inside. I decided to trim a bit less than the box size, so I can account for any walls in the structure, and then these 15 branches could be fit in only 2 boxes. And the thing that can be generated from these 15 branches looks like this. This is a structure that cannot accommodate people right now, but if more boxes are to be used in location, it could accommodate at least 2-3 people in its interior volume. But then I asked myself the question, what if we use local wood instead of bringing the branches from the other end of the world? In that case, we would be able to just bring half a box of one of the boxes with the joint material and save a lot of carbon emissions. So the construction process was a bit iterative. We make several prototypes. This is the first one, which have overlapping joints tied with a rope, and then we investigated different types of connections with wires, washers, or aesthetically coloring and Here is more in-depth video of the assembly process. Here we are cutting the branches so that they can fit into the box size, and also a small margin was cut out for the joint insert. And as you can see, the branches fit quite compactly on this card, and you can see the joints. On the next slide, the next picture, you can see the joints are screws that are continuation of the center line that could be connected at one point using wires. And this was the first step, and the second step was to make these joints more rigid by using paper clay that would harden and have more aesthetical appearance. And in the end, actually, this paper clay looks like that, but it's not waterproof. So in order to make it waterproof, it had to be covered by some kind of natural resin, or in the worst case, epoxy glue, which would increase also its rigidity. And these are other images of different types of joints, and here you can clearly see that the personality of the people that make the joint is evident in each one of them. This joint is made by my colleague Firas, and this one is made by me, and this one as well. Now you can see the difference, and with that I conclude my presentation. Thank you.